Okay, wrong. Okay, so this is April 16th already. It says Wednesday. It is so not Wednesday. It is Thursday. Whoops. Can I change that? Oh, it is letting me. Okay, sorry about that. All right, it is Thursday, and it is April 16th, and this is IPS class. And we are still doing our project space presentations, learning about astronomy together. And today, we are looking at project number 6, the Earth, Moon, and Sun relationships. And August is going to teach us about that today. And we also are going to hear from, good morning, Shelby and Emily. We're also going to be looking at project number 7 today, which is the space race. And JonBen and Elish and Zeke are going to be teaching us about that. And since we've got Nova coming to visit us too. Hi, Nova, welcome. So on Tuesday, last time we were together, we did not get to the second quiz for past and present models of the solar system, which is Evan and Donovan's presentation and quiz. So we're going to be for project number 5, and then we're going to look at August project number 6. And we might not take his quiz, or at least not today in the interest of time. It's listed on a Word document. And then we're going to look at the presentation by JonBen, Elish, and Zeke. They have a Kahoot, but we aren't going to get to their Kahoot until next week. We're supposed to have class Monday, Wednesday, Friday for science next week. Although I just heard a rumor that Monday might not be a student day, might not be a school day. I'm going to find out at 3 o'clock today. Oh, somebody's waiting for me. It's Lily. All right, welcome, Lily. So I am going to find out at 3 o'clock today. Have a feeling I'm going to be finding out that it is a non-student day. I think it's going to be like a teacher workshop day. So we might not be meeting on Monday, and we might not be meeting again then until next Wednesday. So that's going to screw up my my little plan a little bit, but that's okay. We will just keep adding a day. And yeah, so that's our plan. That what you want for class today is just your project space presentation packet, so that you can look at project number 5 for the Kahoot we're going to play right now, and have it ready for answering project 6 and 7 questions. And then maybe your phone for Kahoot. This works the best if you've got your screen, your computer for the Zoom screen and a phone for Kahoot. Maybe you can do them both on your computer at the same time. That I'm not quite sure. Okay. All right. So we're going to start there. We're going to start with our Kahoot. So project number 5, past and present models of our solar system was the topic. And let's try to get to it here. Okay. So with, yes, we are doing a Kahoot today, Jaden. Yes. Okay. And I'm hoping you can see the Kahoot right now. Let's see what happens if I make it big. Oh, I lose my chat, but maybe not. No. Okay. I can still get to you. Okay. So, let's see. Donovan or Evan. Evan, do you see this Kahoot on the screen right now? Libby says she can see it. Okay. Libby, I can see you today. Got to figure out, there should be a better way for me to see everybody. Oh, okay. All right. So here we go. Let's do our classic mode. And there isn't going to be sound, I don't think, but that is all right. And uh-oh. Oh yeah, there it is. Okay. So there is our pin, and remember that you need to put in your name, not just some funky name. If you use a nickname, it's okay if it's one that it's obviously you and it's appropriate. Like Libby writing Lib, I'm okay with that. But I should be able to recognize you, and it shouldn't be anything that's inappropriate. Remember, I have to post this on YouTube, and Austin's coming to join us. All right. Hi, Austin. Welcome. Came in just in time for your Kahoot. Not your Kahoot, but a Kahoot. This Kahoot, Austin, is for project number 5, past and present models of the solar system. All right, getting you in there. Let's see, how many do we have total? All right, the 1700s was the best answer here, and most of you got that correct. It was early times, really 500 BC, when the geocentric model kind of became the dominant worldview, and it stayed that way until about the late 1600s, maybe very early 1700s, when the heliocentric model took hold. And then not until the into the early 1900s, actually middle 1900s, was Kepler's laws the dominant theory. Okay, we got Evan still in the lead, but not by much. Nina's right behind him, followed closely by Maddie and the Lola and Lily. All right, question 3. The church liked the heliocentric model. This is a true-false question. Nice picture of the church there. The church liked the heliocentric model, where the sun was in the middle and all the planets orbited the sun in perfect circles at a constant speed. And most of you, twice as many of you knew the correct answer than the wrong answer. But the church did not like the heliocentric model because the church liked the idea of the earth being in the center of everything. And anybody that went against the earth being in the center actually was arrested. And Copernicus, who thought the heliocentric model was the correct model, actually was under house arrest for the rest of his life. So the church definitely did not like the heliocentric model. This was the Catholic Church. They kind of ran things at the time back in the Renaissance period. Okay, Evan still in the lead, followed by Nina, Maddie, the Lola, and Saya has just thrown Lily out of the leaderboard and jumped on. All right, next. All right, I think there's 2 more questions. Come on, here we go. All right, what does Kepler's first law involve? Does it involve the square of the orbital period of a planet is proportional to the cube? Does it involve the speed of the planet increases as it nears the sun and decreases further away? Is it planets rotate in elliptical orbits, or planets are actually stationary? All right, planets rotate in an elliptical orbit is the correct answer for Kepler's first law. And most of you got that right. Second law has to do with the speed of the planet, and the third law has to do with the orbital period. None of them actually have to do with the planets being stationary. All right, and Evan is still in the lead, no change on the leaderboard. And we got our last question. All right, another true or false question. The geocentric model center is the sun. True or false? In the geocentric model, the center is the sun. All right, most of you got that right. Think about the word geocentric. Geo means earth and centric for center. So earth-centered, where helio means sun. Heliocentric is sun-centered. All right, so let's check out the podium. All right, Maddie Herbert got 3rd place. Then Nina 2nd. And 1st place is Evan. All right. I am writing this down and I'm going to give you guys dojo points. But I have no idea what you're going to use the dojo points for. But heck, why not? It's something I can do. All right. So, good job there. And those are our scores. They were all pretty close. Oh, and it looked like Lola and Reese were right behind those 3. Okay, good job. And I am now going to go back to sharing the slide with you for just a moment here. Okay, so we just did our Kahoot game for past and present models. And coming up next, we've got our Earth, Moon, and Sun relationships, which is project number 6 in our presentation packet. So you want to have that handy. This is going to be a presentation brought to you by August, who did a smash-up job on this. So without further ado, I am going to grab that for you, I think. Okay. Oh, Elish got kicked out. Okay. Elish get back in. He didn't. All right. Sorry, Elish got kicked out. Oh, Evan reminded me that it's his Kahoot. He shouldn't get points. Of course he should win. Yeah. Well, I'll give you dojo points anyway. It's a good Kahoot. Okay. Sorry, Donovan, that your phone was dead. Okay, so here we go. August, this is yours. I'm going to unmute you for a second here. August, do you see a black screen right now? And actually, do you see your video showing up right now on our screen?
Yes, I do.
You do. Okay, perfect.
I see my PowerPoint.
You see your PowerPoint. Okay, excellent. That's what I want you to see. And Alejandro is joining us. Welcome, Alejandro. You are just in time for August project number 6, Earth, Moon, and Sun relationships. And you just missed our Kahoot game from Donovan and Evan's project from Tuesday. All right, here we go. You are in your packet on project number 6. And this one's a little long, so I'm going to do my best to stop it for you, and then you can always ask August some questions at the end.
Earth, Moon, and Sun relationships. Earth's movements affect day and night length and year length. Day and night are caused by the rotation of Earth on its axis. The changing lengths of days depends on where you are on the Earth and the time of year. A solar day is the time it takes for Earth to rotate once. It is also moving around the sun and takes 365 days to travel around the sun.
All right, I paused for a second. So I think your first question, if I remember correctly, is something to do with, what is a day and what is a year? So August is explaining here that a day is how long it takes for the Earth to go around or rotate on its axis one time. That takes 24 hours. But one day is defined as the time it takes for the Earth to rotate on its axis once, and a year, and do you say that? Yes. It takes 365 days to travel around the sun, the Earth around the sun. That's 1 year. Technically, it's 365.25. So every 4 years, we add a year to our calendar in February. Or not a year, a day. One extra day in February every 4 years. Okay, here we go.
Conditions affected by Earth's tilt on its axis. Daytime is shorter in the winter than the summer because Earth's axis is tilted 23.5 degrees. As Earth moves around the sun, the northern half of Earth is tilted toward the sun in the summer, making the daytime longer than the night. In winter, the Earth tilts away from the sun, and the nighttime becomes longer. During the March and September equinox, day and night are both about 12 hours long because neither hemisphere points towards the sun. Season. Earth rotates on its axis and orbits the sun.
Oops. I meant to pause that a second ago. I think, well, we're still talking about it, but yes, he's talking about the reason for the seasons is the tilt of the sun on its axis. And he's explaining that more here.
But it always points in the same direction. Summer happens in the hemisphere pointed toward the sun, and winter happens in the hemisphere pointed away from it. So I have a video explaining it. Be demonstrating.
The sun's energy hitting the northern or southern hemisphere more directly as it orbits the sun on its tilted axis. You can see the Earth's axis is pointed in the same direction all year round. Here we see the Earth on the 22nd of September, the autumn equinox, when the northern part of its axis is pointing neither towards or away from the sun, and the night and day are exactly the same. Next is the winter solstice on the 21st of December, when the northern hemisphere is pointing away from the sun. Then is the spring equinox with equal days and nights again. Then is the summer solstice with the longest day in the northern hemisphere and the shortest day in the southern hemisphere. Then finally, we are back to the fall equinox. The term equinox comes from Latin terms for equal and night, equinox. That is why the seasons are caused. Seasons are caused.
Moon phases. The moon's phase depends on its position relative to Earth and the sun. New moon. Moon, Earth, and sun lie along the same line since the...
Sorry, I pause again for a second. I saw you guys messaged me that my chat window was in the way, so I was moving that. I wanted to make sure, August, can you hear your video? Was the sound working?
Yeah, I can.
Okay, I know it's a little bit lighter, or the volume is a little lower, but I can hear it. I hope you guys can too. Okay, and that was a really cool demonstration. He showed us at the seasons, and now we're talking about the phases of the moon. I don't think you have to write anything down for this, if I remember correctly.
The sun is behind the moon from Earth's perspective. The side of the moon that faces Earth is dark. Full moon. The three lie in a line with the moon and on the opposite side of Earth. So the sun illuminates the whole side facing Earth. First quarter / last quarter. The moon lies perpendicular to a line between Earth and the sun. Half the moon is lit by the sun, the other half is a shadow. And I have a video explaining.
This demonstration, I'll be using the moon, this foam ball, the Earth, my head, and the sun, the lamp, to demonstrate the phases of the moon. So in this position, you can't see any of the light reflecting off the moon from the sun from the Earth. But if I move it to my left slowly, we can see the crescent moon starts to form. If I keep moving it, we can see more and more of the lighted side. Eventually, we can see half of the moon. Once I move it this way, it's a complete full moon. Then I start moving it back this way, and it gets smaller and smaller. Until it's back to the new moon.
Solar eclipse occurs when the new moon passes directly between the Earth and the sun. This casts a shadow on the Earth and blocks the sun and blocks the Earth's view of the sun. Total solar eclipse is when the moon's shadow completely blocks the sun. Partial solar eclipse is when only a portion of the sun is out of view.
Okay, pausing it for just a second. I think you need to just, I think it asks you to either write or draw the lineup of the Earth, Moon, and Sun during a solar eclipse. So you want to either draw or write. For a solar eclipse, you've got your sun, then the moon, and then the Earth. So the moon's in the middle on a solar eclipse.
And I have a video explaining it.
So the sun is 400 times larger than the moon, but by sheer coincidence, it's 400 times farther away from Earth. And when it passes and when the moon passes in front of the sun, it can completely obscure it.
This is cool. Look at that. Small ball kind of hides the bigger ball just because it's closer.
A lunar eclipse occurs when the moon moves through the Earth's shadow, when the Earth is between the moon and the sun, and all three are lined up. A total lunar eclipse is when the moon travels completely in Earth's umbra. Partial lunar eclipse, only a portion of the moon enters Earth's umbra.
Okay, so the lunar eclipse, you've got the Earth in the middle. So sun, Earth, moon.
And here's the video.
So this is the sun, this is the Earth, and this is the moon. And a lunar eclipse is when the moon passes behind the Earth's shadow or aura, and it's completely blocked out.
A blue moon is the same color as the regular moon, but if the moon looks blue, it's due to dust particles in the air. Seasonal blue moon is the third full moon in an astronomical season, with 4 full moons instead of 3. Monthly blue moon, the second full moon in a month with 2 full moons. Either a blue moon occurs every 2 to 3 years. The next blue moon is October 31st, 2020.
On Halloween.
A tidal force is when water bulges toward the moon because of a gravitational pull.
Yeah, okay. I think you have a question here about tides. What causes the tides? The gravitational pull of the moon.
Regions of Earth pass through the bulges, they experience high tide. And here's a video. It does a really good job explaining it.
Okay, I resumed.
Okay.
We usually think of the moon in orbit around the Earth as the Earth stays still. But that's not quite right. Actually, they're both in orbit. They're in orbit around a point called the common centre of mass of the Earth-Moon system. Essentially what's happening is something like that, although it's quite difficult to do. Now, when things rotate around in circles, other forces come into play. In this case, a force called the centrifugal force. So that's a force you'd feel if you're hanging onto a roundabout going faster and faster, and you have to hang on tighter and tighter because of the force trying to throw you off. That's the centrifugal force. Now, let's bring the moon back. So now there are 2 forces at play in this system. There's a gravitational pull, the moon, going to pull everything towards it, and there's that centrifugal force trying to throw everything off. But think about the ocean here. That's closer to the moon, and so the moon's gravitational pull wins, and you get a tidal bulge. Now think about this point, on this side of the Earth. That's farther away from the moon, so the centrifugal force wins, throwing the water off, and you get a tidal bulge. Now the Earth just rotates underneath those tides once a day, and that's why you get 2 tides every day.
And that's it.
Okay. And okay. Okay. I think it's stopping the sharing. Did I stop it? Okay. All right, cool. So I like that. I like the incorporation of the models in the video. I hope that you could hear that video. It was a little bit choppy, but he was talking about why we have 2 high tides and 2 low tides, and about the rotation and how the moon will influence the tides more than the sun does because it's closer. All right. Okay, so we are going to save the quiz for now, and we're going to move to our next presentation. Actually, we're going to open it up for questions before I move to the next one. So let's see here. I'm going to close my chat, and okay. Oh. So Alejandro is asking about the spring tide. It's question number 6 on the sheet. Oh, yeah. He maybe didn't, I'm not sure if he addressed the spring and the neap tides. I don't remember if that was on his sheet. Okay. August, do you know anything about the spring tides? August.
I put a lot of stuff on it on my last slide.
On your last slide, so I should go back to the last slide?
Yeah, just let them.
Okay, let me try to do that here. Oh, and Kyla, I see, raised her hand too, so we're going to go to Kyla here in a second.
So this is Earth, Moon, and
Oh,
Sun.
sorry, you guys can't see this yet. That's weird. Oh, there it is. Okay. Share screen. Okay. There's that. And then last slide before him, right?
Toward the moon, because
That's your last slide, I think, isn't it, August?
Can you say that again? I couldn't hear it.
Is this your last slide, August?
Is it? I don't think that is. I thought I put it on my last slide.
Is it after the video?
Wait. What slide?
Okay, so
I'm confused.
I can help you on that. I'm not sure that you actually talked about spring and neap tides. And
I thought I did.
Did you? Okay, then that's that slide before there. And then your lunar eclipse. Okay. All right. Well, I'm not quite sure if it's in there or not. So let me help you answer that one, Alejandro and August. And that is that you have.
Here, if it's not in there, I can just explain it.
Oh, okay. Great.
So, a spring tide is where the high tide is even higher, and a neap tide is where the low tide is even lower.
Think of the moon.
Yeah. Okay. That is right. Good job, August. So your high tide, your spring tides are the highest highs, and your neap tides are the lowest lows. The highest highs happen on like full moons, and when your sun and moon are lined up together, they're both on the same. So you've got extra gravity, and then when it's quarter moons, where the sun and the moon are at right angles to one another, that's when neap tides, the lowest lows. So, I'm sorry, not the lowest lows, the medium, not the highest and not the lowest. Okay. All right. So, Kyla, what's your question?
So, my question was about, I guess I just missed it, but, what was, the reason why the moon changes over the month? Why and how does the appearance of the moon change over a month? It's number 4.
Okay, August?
I mean, if you want, you could just play that video again, the moon phases video, or I could just explain it.
Basically, just explain, like, why do we see different phases? What is it that we are seeing?
Because our view of the moon and the sun is just different. Like, the sun, a little
Does the moon
confusing.
shine?
No, the moon doesn't produce any light. It's the sun reflecting off of it.
Okay.
And we just see the moon in different spots as it orbits around us and as we orbit around the sun.
Okay, good. Does that answer your question, Kyla?
Yes.
Okay.
Thank you.
You're welcome. All right, anyone else? I don't see any other hands up, so I guess we're good. All right, cool. Thank you very much, August, for that good presentation and all of your correct answers. Oh, Nova has a question, I think. Go ahead, Nova. Let me unmute you. There you
The seasons. Did you hear me?
go. You cut out a little bit. Something about the season?
Yeah. For question number 2, what causes the seasons? I didn't catch that.
Okay, August?
It's just, so say the northern hemisphere is pointing toward the sun, that would be the summer, and if the southern hemisphere was pointing toward the sun, that would be the winter.
Right. So why does a hemisphere like point away or towards the sun? Like, what makes it?
Because the Earth rotating on its axis as it orbits.
There's a better reason. The Earth does orbit and rotate on its axis, but does it do it straight up and down?
No, it's tilted.
Yeah, that's your reason for your seasons, is the tilt of the Earth on its axis, which you correctly identified in the presentation. Did you get that one, Nova? The tilt of the Earth on its axis? All right, great. Okay, I am going to take.
Thank you.
You're welcome. Okay, so now screen sharing is stopped. Oh, okay. All right, now we're gonna play your JonBen, Elish, and Zeke's video about the space race, which is project number 7. And I don't know if you can see my screen yet. Let's see, gotta do something to make that happen. Let's see, I gotta share it. Okay. Okie dokie. So here it is. Let me try to move things out of your way. Project number 7. Here we go. 1, go.
All right. So this is our PowerPoint on the space race. The space race was a series of competitive technology demonstrations between the United States and the Soviet Union, aiming to show superiority in spaceflight and to be the first to land on the moon.
We find ourselves in 1955 when the space race begins. During this time, the U.S. is fighting in the Cold War. The Soviet Union launches the first satellite, which was called Sputnik, into space. And it's clear it's a big advantage, and other countries clearly see it as well. Sputnik was feared by many Americans because many thought it was armed with missiles. The reason Sputnik got so much attention was because something like this was never done. So no one knew how to react to it, and no one knew how to control the situation. This was also an embarrassment to the U.S. since it showed how the Soviet Union was more technologically advanced. And this is how the space race began.
Okay. Sorry. So I was asked to go back to the previous slide for a minute. So I am doing that.
Was because
I think.
The Soviet Union, aiming to show superiority in spaceflight and to be the first to land on the moon.
Okay, so I am assuming that this is the first question asking, maybe what the space race was or who it was between. Yeah, I think. Reese, can you tell me what is the first question? What's the wording on it?
What was the space race?
Oh, okay, it was just what was it? Okay, yeah, there you go. So, series of competitive technology demonstrations between the U.S. and the former Soviet Union, which is Russia. Yeah, okay. All right, so let's kind of go back here.
Canaveral, sorry.
I think we're gonna go. Oops.
it's how the space race began.
The U.S. strikes back. Only after 4 months, the U.S. finishes and sends the Explorer 1. It was launched into Earth orbit by the Army on January 31st, 1958, at Cape Canaveral, Florida. Surprisingly, the satellite only weighed around 181 pounds and was 80 inches long.
All right, I'm pausing for a second because I see a message from August saying he can't hear anything. Can you guys hear this?
You have to have like the app open. It wasn't working for me either when I was on my phone. You have to have like Zoom opened up to hear anything.
Oh, okay. All right. So August, you have to open up Zoom to hear it. Maddie's saying she can hear it. Okay. So yeah, I think that's what you need to do is just to open up the Zoom all the way. Okay.
Satellites, in the context of man-made objects, are machines that are put into orbit by humans, usually for the purpose of research and study of space, like Hubble and the ISS for communication purposes, or for communication purposes. They help us access any data faster or quicker wherever you are. These satellites also help us predict Earth's forecast on any possible harm headed towards Earth. They also had spectroscope technology. Spectroscopes are an instrument used to measure the various properties of light waves by splitting them into its full spectrum. This was crucial to scientists. Spectroscopes allowed them to determine what an object in space was made from, its density, its temperature, and its age, just based on the spectral lines coming from the object.
All right, I paused it for a minute. Not sure if this question is about satellites, maybe. So I'll go on. I don't see anybody raising their hand for this or saying anything, so maybe we're good.
The space race. The Soviet Union was the first country to send a man into space. On April 12th, 1961, aboard the spacecraft Vostok, I think that's how it's pronounced, Soviet cosmonaut Yuri Alexeyevich Gagarin was launched into space from Baikonur Cosmodrome. He became the first man in space and first to orbit our planet, a total of 89 times.
U.S. time to shine. After much frustration and failed trials, the U.S. was the first nation to land men on the moon. They were on Apollo 11, where they launched from the Saturn V rocket, which remains to this day the largest and most powerful rocket ever built.
You might remember Chris Fields, our
space shuttles. A space shuttle is a spacecraft that can land like a traditional aircraft and can be reused. The U.S. space shuttles were the Enterprise, which was a prototype that never went into space. Then we had the Atlantis, Challenger, Columbia, Discovery, and the Endeavour. The shuttle program was launched in 1972, but the first launch was not until April 12, 1881, and its final flight was by the Atlantis on July 8, 2011. The end of the space program saw a major drop in Florida's space economy, as nearly 2,000 jobs were lost from Kennedy Space Center. However, it paved the way for many other small companies to get involved in space exploration and are working with NASA to advance the concept of deep space travel, which is starting to rebuild Florida's economy.
You might remember our guest speaker before we went into quarantine, Chris Fields. He talked to us about those private companies getting involved with NASA to go to Mars and the moon again.
The ISS, the International Space Station, is a man-made satellite in low Earth orbit. It is approximately 225 miles above the surface of the Earth. The people who live in the station are crews from NASA and all around the Earth who research in astrobiology, astronomy, physical sciences, material sciences, space weather, meteorology, and human research, including life and medical science. It is also used as a research facility for possible missions to Mars and other deep space travel.
Okay, I will get to that in a minute. That is the model, one of them.
Hubble Space Telescope. Hubble Space Telescope was launched into space for the purpose of gathering light from cosmic objects to help us pin down the age of the universe. Wait.
Yeah, you got it.
My dad's calling me.
Oh. All right, well, I'll pick up.
Wait, no,
Which we know now to be around 13.7 billion years old. It also helped us discover galaxies that we believe are from the early times of the universe. It has also discovered 4 of the 5 moons of Pluto. The lenses and mirrors inside the telescope focus light. This light is what we see when we look into a telescope, showing a magnified image of the object. The earliest known telescope was made in 1608 in the Netherlands by an eyeglass maker named Hans Lippershey, I think.
Lippershey.
Telescopes have helped us learn about the universe around us. The earliest telescopes proved that the Earth was not the center of the universe. More modernly, they have helped us discover objects billions of light years away by detecting the radio and X-rays they emit. Voyager and Galileo are 2 of many that have discovered galaxies that we used to think were just clouds of dust. Thank you. And that was the cake that we were going to use as our model, but we never did. Hey, it tasted good.
It's beautiful. It does look like it would taste really good. I'd like to eat it right now. It looks really pretty. What a pretty cake.
And we do have a quick thing. Let me just... so this is the 3D model of the International Space Station. It's very detailed. It has all the docking bays.
Yeah, I'm sorry. Did you pull it up?
I don't see it either.
You're going to see it in a second.
Oh, I have to...
hit share.
Share.
Yeah, hit the share.
This one. All right, that should
There
be
it is.
So, oops. So this is the model of the International Space Station. Yeah, basically you just notice the very big solar arrays on either side. Those are used to power it. You have the few docking areas underneath it where rockets can connect to it. And there is loads of spectroscopes and telescopes and other scientific tools on the International Space Station.
Can I say something?
Yeah.
Okay.
And actually, guys, I am going to stop it there. Whoops. We'll leave it here for a second. Yeah. So
the International Space Station.
Last couple minutes where we're kind of just shooting the breeze together. This is pretty much it. So I really like this 3D model. It's pretty neat. And the cake. All right. Anybody have any questions? Let's pull up my chat again. I know somebody wanted me. Kyla said she wanted me to go back to the slide before the space shuttles and go back to the first man in space. Okay. All right. So first man in space. Yeah. That was that.
Space telescope. Hubble Space.
From Kennedy Space Center.
Let's see. I think it was back further.
Apollo 11, where
it was right before that.
1961, aboard the spacecraft Vostok. I think that's how it's pronounced.
Yeah. So here's the first man in space. You could just call him I can't remember if I asked you for his name or not, or just where he was from, but he's from the Soviet Union, and his name was Yuri Gagarin. It was in 1961. He orbited the Earth 89 times. And then, let's see, Kyla wants to know about I'm not sure what you're asking for, Kyla, but it was the slide before
which remains to this day the largest and most powerful rocket ever built.
Kyla, what's your question? Or do you have one still? Kyla? Oh, whoops. Okay, that was it. Okay, thanks. Oh, very nice. So you got some compliments here. Jaden's saying that this was really good. I agree. Okay, anybody have any questions about it? I think we're going to take the Kahoot. Yeah, we're going to do the Kahoot on it next week because there's about 7 minutes. We could probably fit it in, but it'd be too tight, so we won't do that. So we'll save the Kahoot. Let's see, Lily, can you go over satellites and spectroscopes? Yeah, sure. Would one of you guys like to explain a little bit about spectroscopes and telescopes? I'll try to find the slide too.
Sure, I'll repeat that.
This space weather.
Oops. Okay.
So a spectroscope, we learned about them, is a tool that refracts light into its spectrum. It helps scientists determine a star's age, its volume, its temperature, and what the star is made of.
Yeah. And I'm just not. Oh, there it was. Okay. All right. Yeah. There.
Oh, and the telescopes?
Yeah. Or she says satellites, actually.
Oh, satellites.
So what is a satellite? Like, what would be a simple definition of a satellite? Or
satellites are a man-made object that we send into space.
Okay, they can be.
Or they can be like moons.
Yeah, they can. So natural satellites could be like moons, or even planets are natural satellites. And then we've got our like GPS and, cell phone service and internet and all that stuff, satellites that are man-made. What do they have in common? Oh, let me unmute. You can, you can unmute yourself, but I can do it too, Elish. It just, there, I unmuted you, Elish. Go ahead. At least I think I did. Yeah.
Hello?
Hi.
Hello. Sorry, can you repeat the question? I didn't hear you.
Oh, the question was, what is a satellite? And JonBen was saying, that we send artificial satellites into space for things like GPS. And we also said that natural satellites could be like moons or planets. So my question was, what do they share in common? A natural satellite and an artificial satellite? Trying to get to like a real simple definition of a satellite here.
I mean, I guess if you want super simple, it's just something that orbits something else.
Yes. And something else that it orbits has to be larger. So when an object orbits a larger object. So yes, that is right. So when a planet orbits the sun, the planet is a satellite. When the moon orbits a planet, the moon is a satellite. We have ISS is a natural satellite, is a man-made satellite that is orbiting the Earth. Hubble Space Telescope also orbits Earth. So those are satellites. And then all of our little satellites we launch to get us our internet and TV and radio stations and stuff are artificial satellites. Any other questions for Elish or Zeke or JonBen? Trying to look through all you here, see if I see any hands up or any chats. I don't see any new chats or any hands up, so I guess that must mean you don't have any more questions. All right. Well, that's good. That must have covered everything. Excellent. Somebody asked who made the cake? Yeah, JonBen made the cake, right? Didn't you, JonBen? Did you make it with
Yeah.
your
It
mom?
was
Yeah.
Donovan's mom. She's like a professional cake maker or something like that.
She did.
She did such a great job.
Yeah.
You helped her too, did you say?
Yeah.
Yeah. Okay, awesome. And the 3D model of the ISS is really cool too. All right, guys. Well, I am happy that we made it through without going overtime. I'm trying to learn to not push so much stuff into one period, even though we don't meet that often anymore. Do you guys all know, I hope that you do by now, we are no longer going to take exams. So you are not going to have an exam on all of this. You will take a test on our project space, on our astronomy unit. So you will have a fourth quarter grade, but you just won't have an exam. So just letting you know that. I had the exam planned. The exam is still almost 2 weeks out. We need to finish the rest of the presentations, and then we'll have a few days of review. And then you'll have a study guide while we're reviewing, and then we'll take a test. And then we'll move into some fun physics stuff before we finish the year up. So might not be having school on Monday, so you might have another 3-day weekend. All right. Anybody have any just general questions? I'm gonna try to unmute everybody. And if anybody wants to talk or say anything, you can do that. I think I got you unmuted. I might not. Okay. Well, let me first of all stop recording.